It's here! After almost 3 years, Bambu Lab has finally released their new Core XY 3D printer, the H2D. This is the large machine that so many have been waiting for, offering more than twice the print volume of its predecessors. While it might still disappoint some, this machine has all the bells and whistles that makers expect in a digital fabrication system. Yes, I didn't call it a 3D printer, because the H2D can be more than just a 3D printer. And one of the most exciting aspects might not even be the 3D printer itself. Let's take a closer look at it and see where it shines and where it still needs some polish. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. This video is sponsored by Voxel PLA. Their Voxel PLA and Voxel PETG work perfectly with Bambu Labs multi-material system and sells for only $16.99 per kilo. Check out their filament lineup at voxelpla.com. Yes, the H2D is finally here and it's available at Bambu Labs warehouse worldwide, not just as a pre-order or a Kickstarter. You can find a link down in the description, which also supports my work over here. There is, however, a slight caveat. As you may have heard, the H2D is more than just a 3D printer. It also comes as a laser combo with either a 10 watt or a 40 watt laser unit featuring green tinted windows for laser protection. The standard H2D is in stock now, along with the new AMS unit. But the laser combo will still take a few weeks to ship and is currently only available as a pre-order. Whether it makes sense for you to wait for the combo or if the 3D printer only version suits your needs is something you'll need to decide yourself, and I'll help you figure this out during this video. For completeness, there will be an upgrade path for the standard H2D to the H2D laser combo if you later decide that you want to have this additional feature. A quick word about pricing. The H2D starts at $18.99 for the printer itself. The combo, which includes the AMS2 Pro, costs $2,199, while the full combo with a 10 watt laser is priced at $2,799. And if you spend an additional $700, you'll receive the 40 watt laser instead. The H2D targets the more professional maker market, but it's not as expensive as many have expected. But let me know your thoughts about the pricing in the comments. By the way, I'll also have the chance to talk to Bambu Lab and Dr. Tao next week, so if you have questions about anything regarding the H2D, then leave them down in the comments. The H2D honestly has too many new features, more than I can cover in this video. However, if you really want to explore all details, I recommend checking out Bambu Labs resources linked below. First of all, the new machine is large and weighs over 30 kilograms, which definitely makes it a two-person job to get it out of the box and onto your workbench. What contributes to this machine's weight is the die-cast aluminum frame for the motion system, along with numerous aluminum, steel, glass and injection molded parts that make up the machine. Something that many X1C users will celebrate is that it finally uses a linear rail for the X-axis, although it still comes with linear rods for the Y-axis. Overall, it looks very clean and professional. Everything is well machined or injection molded and fits together perfectly. There is no part of the machine that feels cheap or flimsy. Well, I must correct myself slightly here. Whereas the door on the standard H2D is glass, the laser protection door and the side panels on the laser combo are plastic and a bit wobbly, plus they are prone to scratching. Anyways, the front of the machine features a tiltable screen that is similar in size to the one of the old X1, but with a completely overhauled user interface that feels notably smoother to use. There are still some aspects that are a bit confusing and not functioning perfectly, but I have heard they are working hard to enhance the user experience, and they have already ensured that the user experience feels quite friendly. By the way, the H2D can now be fully set up and firmware upgraded offline using a USB drive without ever connecting it to Wi-Fi or register it to a Bambu Lab account. If you want to utilize the MQTT interface, like with the old machines, you can activate developer mode, but that will lose you remote monitoring capabilities over the Bambu Lab cloud. When looking inside, we find the new large heated that can reach up to 120 degrees Celsius and comes shipped with a textured PEI sheet that generally works well for print adhesion. A nice detail here is the indicator light bar, which also serves as a progress bar during printing. The maximum print volume is 350 by 320 by 325 millimeters, which is more than double the volume of the X and P series printers, though perhaps not as spacious as many have hoped for an XL Bambu Lab printer. If this is a deal breaker for you, let me know in the comments. Unfortunately, in most prints you won't be able to utilize the full 350mm of width. This is not due to the filament cutter, but rather a consequence of the new dual nozzle print head. Since the nozzles are spaced apart, the left nozzle can't reach all the way on the right side of the bed, and the right nozzle can't reach all the way to the left. This results in a printing width of 325mm for single nozzle prints, and if you're using dual nozzles, this is further reduced to only 300mm, which may be disappointing for some. Personally, I don't mind this too much, as I find the size is adequate for most of my prints. However, it is still significantly smaller than a Prusa XL, for example, which can print 360mm in all directions with every tool head. Nevertheless, the print volume is still slightly larger than the one of the new Ultimaker S8. Why do I compare it to the Ultimaker though? This is because the way Bambu Lab approaches multi-nozzle printing is quite similar to Ultimaker's method. You might think this is a ripoff, but it's not, as they have made significant improvements with one particular feature. The left of the two nozzles is adjustable in height. When used, it's lowered, and when inactive, it retracts. This way, only the active nozzle touches the print during operation, preventing interference from the inactive one. But it's not just about mechanical interference. The worst aspect of having two nozzles at the same height is that a small amount of material always oozes out, which can ruin the appearance of your print. By lifting the nozzle, the likelihood of this material landing on your part decreases, but it always has been a challenge on the Ultimaker, especially if you're using materials that aren't perfectly dry. Here's where Bambu Labs technology shines. They have implemented a tiny nozzle cover that automatically swivels over the inactive nozzle, preventing oozing and resulting in perfectly clean prints. The hot ends themselves look almost identical to what Bambu Lab uses on their A1 series of printers, where changing the nozzle involves simply removing the silicone sock, opening a clip, and tilting the hot end out. The heater and thermistor are located at the back and are attached to the print head, which saves on cost and reduces hassle while maintaining the risk of breaking wires or connectors. However, there are internal differences that optimize flow, making them not fully compatible with the A1 hot ends. Additionally, a high flow version is available that claims to increase the flow rates from 40 to 60 cubic millimeters a second, but I haven't tried it yet. I'm even considering cutting one open to compare how it works to a regular CHT nozzle. Let me know if you would be interested as well. By the way, the printer can now recognize the type of hot end installed through a small data matrix that's laser engraved on the front, preventing accidental printing with the wrong hot end or nozzle size. This is a similar technique they also use to distinguish build plates. Another quick note about filament feeding on the H2D print head. They do not use two feeding motors. Instead, there's one central gear and motor, along with swiveling idlers that push the filament either on the left or on the right. This clever approach saves weight. The motor design is another innovation. They use a self-developed servo motor that allows them to measure torque for tasks like clogging or jam detection, and I believe they also use this technology for pressure advanced calibration. This change means that the micro lidar previously used for flow calibration is no longer present on a tool head. However, there remains a downward facing camera for recognizing the print plate and other functionalities, and notably they now have a nozzle cam installed that should enhance print failure detection. There have been instances where the AI detection worked perfectly, but others where it didn't. Whether this was due to the selector sensitivity, I can't really say at this point. Unfortunately, this camera cannot be monitored in the slicer or the app yet, which I think would be a nice feature. Since the H2D is capable of both dual nozzle and multi-material printing, there are filament cutters on each print head to cleanly snip off the filament when it retracts to the AMS. The cutters are now activated by a sophisticated mechanism, eliminating the print areas on the print bed where printing was previously impossible, as we had on the X and P series of printers. After discussing so many specifications, though still far from all of them, let's look at some print results, because isn't that what matters the most? Let's start with a single material print. What else besides a 3D band sheet could I print? Printing is actually quite quiet due to the linear rail and enclosure. The only noise you usually hear is from the fans. With the default profile at 0.2mm layer height, it took 47 minutes to finish. It wasn't the fastest, but compared to other printers' default profiles, it's definitely comparable. The results look great, with hardly anything to complain about. The surfaces were super smooth, the extrusions very consistent, and there was no ringing or VFAs. The only thing to mention is a bit of over-smoothing from the input shaper, which caused some details to be smoothed out. The underside also looked perfect. Then I printed the speedboat race Banshee that was pre-sliced on the machine, and it took 23 minutes. It also looked basically perfect, but showed slightly fewer details due to thicker layers. Additionally, the other parts I printed were almost perfect, except for some slight and fine stringiness. Next, I printed Boba Fett overnight, and the morning when I checked it, I was seriously concerned due to the rough texture that I saw. However, after reviewing the slicer, I realized that these weren't printing defects, but rather the texture of the highly detailed model that the H2D reproduced exceptionally well. So this is a very good start. The PETG parts also look good, aside from some stringing, and the ASA and CF nylon parts came out perfectly, partly due to the heated chamber in the H2D. Yes, one of the significant features that make the H2D a professional machine is the capability to actively heat the chamber up to 65 degrees Celsius. This significantly helps reducing warping on larger prints made with technical materials, and also enhances layer adhesion, as I demonstrated in a previous video. If the bed and heater operate in parallel, reaching 60 degrees Celsius, which is usually the default for many technical materials, takes around 10 minutes. US machines, or rather those using 110 volts, might be slower due to their considerably lower power rating compared to the 2200 watts available in 230 volt regions. The printer is equipped with a properly sized HEPA and charcoal filter to minimize odors and particles emitted during printing. When the active heater is used, the internal air is recirculated through this filter, continually cleaning the air and reducing the smell around the machine while printing ABS or ASA. The air management system is also active and will not only close the exhaust when printing high temperature materials, but it also doesn't require leaving the door open when working with low temperature materials like PLA. When using these filaments, a vent automatically opens on the top of the machine, allowing a constant flow of fresh air from the front. Our press material mentioned that in this situation the exhaust should be filtered, but at least on my 2 units the shutter isn't closing yet. I hope this is addressed soon. Still, it's pretty cool and seriously hassle-free. Printing more than one material leads us to another significant topic: Bambu Labs' new AMS systems. Yes, plural, because they are now the AMS2 Pro and the AMS HT. This is also the perfect opportunity to introduce today's video sponsor, Voxel PLA. Voxel PLA's Pro PLA and PETG are among the most affordable yet reliable filaments available. They sell for just $60.99 a spool, and they offer free shipping in the US if your purchase is over $65. Voxel's materials are great for high-speed printing, and I used them for most of the prints in this video with great success. Last year, I even tested their reliability by printing an 8-color version of Zelda's Majora's Mask on one of my other Bambu Lab machines, which took 6 days, involved almost 3,000 material changes, and I had no issues whatsoever. They have a variety of colors to suit every taste and also sell 3D printing accessories. My favorite is their X filter for Bambu Labs X and P series of printers, which combines a HEPA and activated carbon filter to keep your workspace air clean. So if you live in the US and are looking for handy accessories or want to stock up on filament for your next big project, check out Voxel PLA at voxelpla.com. Now let's talk about the new AMS system, starting with the more familiar one, the AMS2 Pro. If you place the old and the new model side by side, you won't spot significant differences. It's the same size, still holds 4 spools, and remains a bit limited in terms of compatible spools. However, if you look below the rolls, you notice one game-changing feature for anyone who has ever had to clean a clog or replace a Bowden tube on the old AMS. The Bowden tubes are now easily accessible, making troubleshooting much simpler. The feeders look quite similar, but they operate more quietly and feature a ceramic inlet that shouldn't wear out so quickly. So, what makes it Pro? The old AMS was simply a filament storage solution, but the AMS2 Pro now can also dry your filament. This might not seem groundbreaking to many, since others like Anycubic already have that feature in their multi-material unit. However, Bambu Lab is the first to do it correctly. Their system is really smart, and I hope others will adopt this approach for their filament dryers in the future. When you dry filament, the moisture from the material transfers into the warm air, but when the air becomes saturated, it stops effectively drying the materials. If you leave your standard filament dryer closed, it won't function properly, and you can only count on a leaky housing for some air exchange. I often either regularly open or leave a gap in the lid of my dryer to allow fresh air to replace the moist air. The AMS2 Pro will handle this automatically. The unit has 2 active air vents to expel moist air and get in fresh air. Once you start the drying process, those vents are opened, and when the preset time is over, they close again, sealing the unit airtight. All of this happens automatically, making the AMS not only a dryer, but also a really good storage solution. The AMS HT, which accommodates only one spool, operates similarly. It includes the vents, but the heater can reach up to 85 degrees Celsius, allowing it to dry more technical materials. It has an external screen displaying internal temperature, humidity, and remaining drying time, and connects directly to mains power. To ensure uniform drying, both units will slowly rotate the spools throughout the process when filament isn't inserted into the feeder. In fact, when drying PLA, the AMS won't allow you to start the drying process until you disconnect the filament to prevent issues when the material softens during drying. The AMS HT is also designed to work with both very flexible and very stiff material, which wouldn't work with a standard feeder, and these materials can be fed outside the AMS by using a bypass. Kudos to Bambu Labs, because the new AMS units will work with the old X and P series printer after a firmware update. Additionally, the old AMS will function with the H2D, allowing you to save some money by purchasing the H2D without the new AMS if you already own an old one. You can also daisy chain up to 4 AMS units for serious multicolor printing. Actually, you can connect up to 4 AMS2 Pros plus an additional 8 AMS HT to the H2D for a total of 24 material printing, if anyone ever needed that. Let's discuss dual material printing, which the H2D should be really good at due to its dual hot end print head. I began with a simple panel model. To use the two tool heads, you need to feed the material separately from the back. If you have an AMS, it will connect to one of the ports. With 2 AMS units, you can connect the other one to the second port. If you don't have 2 units, which most likely won't be the case, you can simply use the external spool holder on the side to feed the filament spool. The process can still be a bit tricky, and I hope improvements are made to the user experience here. However, once you load the material and assign its type and color, you can easily select them in Bambu Studio for your model. Since we use 2 nozzles, they must align with each other, or rather we need to know the offset between them. To do this, Bambu Lab equipped the back of the print head with an eddy current sensor that measures both nozzles before each print, ensuring perfect alignment even if you change the hot end. Because it's an eddy current sensor, it detects only the metal, enabling precise measurements of the nozzle regardless of whether it's dirty or not. Now onto printing. Once one color is finished, the print head quickly moves to the back, changes nozzles, switches filaments, and then continues printing. This process is significantly faster than using a single nozzle with the AMS like Bambu Labs' other printers. For the Panda, the old method took 5 hours, while the dual nozzle mode only takes 2 hours, making it almost 3 times faster. This not only saves time, but also filament. The AMS print used 129 grams of material, including waste, while with the new tool head, it only requires 40 grams, which is 3 times less. However, you might have noticed that it still uses a purge tower. This is necessary to purge any degraded material that's sat in a nozzle, and since the extruder disengages when switching filaments, it helps return it to a known position. You can deactivate the purge tower in the slicer, but doing this will result in holes in your part at the start of printing. For now, purging is essential, though I believe it's more than what's truly needed. I hope they can enhance the printing profiles. I also have printed some larger parts with this method, and the results were impressive and reliable. Faster and less wasteful multicolor printing is nice and might be a great use case for some, but where this new tool head really shines is multi-material printing. This means working with 2 incompatible materials that should not be printed through the same nozzle. If you want to learn more about this, I highly recommend checking out a recent video of mine where I compared tool changers with multiplexing systems. This could involve PLA with PETG supports for easy removal and clean bottom surfaces, minimizing additional printing time, and more importantly, preventing any weakening of your print from mixing the 2 incompatible materials in the nozzle. I thought this was an excellent example print, but I noticed that the dedicated support materials unfortunately do not print that reliably. So excuse the mess. Another use case is the combination of stiff and flexible materials within the same print. Here's an example provided by Bambu Lab, demonstrating a bike saddle where the structural part is made from carbon fiber nylon and the cushioning parts are printed from flexible 90A shore hardness TPU. The print completed successfully and showed the capabilities of Bambu Lab's new machine. However, the TPU was a bit under-extruded. This under-extrusion is partly due to the H2D and partly my oversight from not properly following their instructions. You see, the AMS AMS can only feed Bambu Labs' very stiff AMS TPU directly. Anything more flexible requires external feeding. On the H2D, you're instructed to remove the Bowden tube inside the print chamber from the filament buffer and push through the designated flexibles hole in the back. Then you can feed the TPU directly to the print head, which is not very simple due to the friction and the lack of feedback on the screen. Anyway, I was lazy and placed the roll of TPU on the external filament holder, hoping for the best. Unfortunately, that created too much friction, leading to all the under extrusion and ruining my long print. The carbon fiber nylon printed beautifully though. I didn't want to abandon my TPU efforts and followed their recommended procedure for working with very flexible materials, which involves directly feeding the filament without any Bowden tube. So I placed my H2D on the floor, trying to avoid breaking my back, then loaded the 90A TPU from the AMS HT out of the bypass hole and printed a shoe. This time the results were amazing, even though the process of working with TPU feels less than user-friendly. I was informed that they are working on improvements and I hope more practical solutions being available soon, but we'll see. But what happens if you want to print with more than 2 materials or colors? You can either use the traditional method with the AMS and a single nozzle, or take advantage of the new approach by combining the dual nozzles with the AMS. Bambu Labs' approach here is quite clever. Bambu Studio has undergone some significant updates, which are evident not only in the printer and material selection, but also in the new slicing modes for the H2D. By default, Bambu Studio operates in filament saving mode. When working with 2 or more materials, the software indicates where to place each material or color to minimize filament waste from purging and optimize print speed. For my Flexi Octopus, it recommends placing the white PLA on the external spool holder and the other colors in the AMS. This also highlights that you can now print 5 colors instead of 4 with just one AMS, which could be really beneficial for some projects. Unfortunately, this procedure means that you need to rearrange your filaments before each print, but that's not too much of a hassle with the AMS, to be honest. If you prefer not to swap materials manually, you can opt for the convenience mode, which uses the filaments as they are currently in the AMS, potentially wasting both material and time. A nice feature of this mode is that it informs you of how much material and time you'd waste if you don't use the optimal configuration, which could serve as a good motivator. Finally, there's a custom mode that allows you to mix and match materials as you wish. So, in this combined mode with dual nozzles and AMS, you will experience fast material changes when switching between nozzles, but slower changes when changing materials within one nozzle, resulting in the familiar purging poops. Nevertheless, this method is consistently faster than before when solely working with the AMS. For the Octopus, we reduced the printing times from 23 hours to 18.5 hours, for instance. However, due to the slow changes with the single nozzle, we still can't match the speeds of tool changers like the Prusa XL, which can print the 5-color Octopus in even 5 hours less. The print quality is excellent with very few issues. The alignment of the nozzle is effective, especially when separating light and dark colors, preventing any color bleeding. Print times are significantly cut down with the dual nozzles and smart slicing optimization. When printing with 2 colors, the print times can approach those of a tool changer, but you still end up wasting material and time due to the purging requirements. Before I start voicing my complaints, let me briefly discuss another tool that Bambu Lab has introduced. This is the Vision Encoder system designed to enhance the precision of your prints. Every motion system has tolerances, and many of you might have already tuned your steps per millimeter or adjusted your printer skew. The Vision Encoder plate will automate this process for you. It is a precisely printed build plate with thousands of Aruku data matrices. This accessory, once placed on the printer and the calibration process initiated, allows the camera on the print head to scan the entire print plate, correcting its movement to perfectly align with the precision plate. This mechanism autocorrects skew and claims to enhance the motion system's precision to 50 micrometers over the whole print plate. However, keep in mind that this won't account for material shrinkage, so don't expect your parts to be perfectly precise, but they should be closer. I tested the difference before and after calibrating using Vector 3D's Cauliflower and didn't notice any significant difference, likely because the machine was already well pre-calibrated. I view this as more of a novelty since thermal shrinking is probably much greater than mechanical tolerances, but I'm curious about your opinions on this. Would you invest in such a calibration plate? Now for a little complaining. In addition to my TPU feeding issues, I also encountered some other aspects that weren't quite perfect. First, I frequently had bed adhesion problems. When I printed a single layer sheet, I noticed that it wasn't perfect. It turns out that they now have an auto bed leveling check by default to save on print starting time. The H2D probes certain points, and if they are within a specific tolerance, it uses the existing bed mesh and begins printing. After I manually activated bed leveling before the print, it probed the entire print bed and printed a perfect first layer sheet. I thought the problem was resolved. However, I continued to experience bed adhesion issues with difficult geometries consistently in the same area. When I used my thermal camera to check the evenness of the heated bed, I discovered that the H2D appears to use a heating element similar to the A1, leading to a relatively uneven temperature distribution, especially with a cold spot where I had adhesion issues. Additionally, the temperature was about 10 degrees lower than the setting. I know emissivity can be a problem with thermal cameras, but I checked with a thermal couple which reported even lower temperatures. After adjusting my PLA temperatures 5 degrees higher and avoiding these critical areas, I finally succeeded in printing my Flexi Octopus. Another issue that drove me mad was experience a blocked hot end twice after feeding 2 low temperature filaments following an ASA print when the chamber and the components were still reasonably hot. Both times the material softened in the extruder and caused a jam. While this alone wouldn't be a major issue, clearing that jam on the highly complex print head was quite a hassle. Keep in mind that the more complex these machines become, the harder they are to debug and fix yourself. This applies both to the mechanical system and the electronics, so if that's important for you, a DIY printer or a more maintenance-friendly machine might be a better choice. I had several instances of material bleeding on the first layers after switching between filaments. Here I would love to see a smart filament change routine that purges more material when switching between incompatible materials. They have all of the information, so this should be easy to implement. Lastly, I would really appreciate a delayed print start in conjunction with the new drying function of the AMS. Sometimes I want to start a print at the end of the day, but the material isn't properly dried yet. Why not activate the drying cycle and after 2 hours when the outer layers of the spool are dry, begin printing and continuing to dry. That could save significant amount of time and improve print results. Oh boy, that was quite a bit about the 3D printing capabilities of the H2D. But as you've already noticed, Bambu Labs' new machine is more than just a 3D printer. It doesn't aspire to be a full jack of all trades like the Snapmaker, but the H2D features a rail that allows you to attach a laser, a drag cutter, and a pen plotter to the print head. It is worth discussing because Bambu Lab has finally engineered this right. The laser won't blind you, they provide an air purifier, and the software they created for those tools, despite being in its first version, already function quite well. So if you get the H2D laser combo, your machine will look a bit differently. You'll receive the green tinted plastic windows and doors, an additional camera for alignment, an air pump for laser assist, a nice e-stop button, the new tool heads, and suitable build plates. When you want to laser or cut something, you'll need to do a bit of a conversion. Let's begin with the laser. First, remove the toolhead cover to reveal the installation rail. Next, slide the module into place and secure it with a lever. A cable plugs into the back of the toolhead for communication and power, and the air assist hose connects to the pneumatic coupler. You screw a hose shroud onto the printer's exhaust to connect the printer to the optional air filter or directly exhaust through a window if possible. Then, simply replace the print sheet with the laser tray, and you're ready to go. The calibration wizard will guide you through the setup process, ensuring that everything functions correctly. The focus position is measured each time by engraving lines onto a piece of cardboard and then scanning that with the laser head. Then it's off to Bambu Suite, a new software tool specially designed to work with the laser, drag knife cutter, and the plotter. As far as I know, there isn't currently any option to use third-party tools like Lightborn, and I'm not sure if this would ever be easily feasible due to the deep integration that Bambu Lab implemented. Nonetheless, for the first release, it already functions quite well. The only feature I've been missing so far is the ability to import vectors from a PDF and automatic C adjustment for multipass laser cutting. When you start it for the first time, a well-made guide shows you how each step works and how to create your first parts, which is pretty neat. You can add general shapes, text, or even grayscale images to engrave. Once you completed your design, you move to the preparation workspace to select your material. Bambu Lab includes parameters for a set of materials they will be selling, but if you prefer to use your own raw stock, you can do that easily as well. It's crucial to set up the thickness of your piece here so that the image captured by the bird's eye camera aligns properly. You can then arrange and position your design on the part, adjust parameters parameters if necessary, and send it over to the machine for production. I've mentioned it before, but Bambu Lab has taken extensive measures to ensure that this is a safe laser machine, including protective windows, an emergency stop button, a filtration unit, and several flame sensors surrounding the machine and the laser head itself. Still, you'll need to be present at the machine while it's working, as you can't remotely start a job due to the inherent fire hazard with lasers. They ensure safety by requiring you to push a start button on the machine before it begins operation. Once started, it'll open the vents, activate the air pump, and laser your part. Unfortunately, Bambu Labs air filter does not automatically activate when the machine begins lasering. This is a bit disappointing, given all the technology they have. The 10-watt laser is excellent for engraving and cutting light materials up to 5mm thick wood. Because it uses a blue laser, you won't be able to cut clear acrylic, but you can even engrave metals, which a CO2 laser can't do, for example. The 40-watt laser is significantly larger and more expensive, but it will also cut materials up to 15mm of wood faster and easier. However, if you're already spending that much more, you should probably consider investing in a dedicated laser cutter. The ventilation system effectively removes most of the smoke and fumes, but there will always be some residue inside the printer, especially in the motion system. Bambu Labs states that with proper maintenance, it shouldn't impact the lifetime of your printer, but excessive buildup will definitely affect its performance. That said, the system should be perfectly adequate for occasional engraving and cutting tasks, but if you plan to do this daily, you might want to consider purchasing a dedicated unit. I didn't notice any laser light leaking out of the unit, even in a dark room, which gives me confidence in recommending the system if you have a need for it. The drag knife cutter is another accessory that comes standard with the H2D laser combo and will allow you to cut paper, stickers or decals. It's installed similarly to the laser, minus the air assist. Instead of the laser tray, you install this tacky double-sided print plate. The software workflow is similar to the laser, but instead of adjusting the laser power, you can adjust the drag knife pressure, which essentially determines your cutting depth. My first attempts at aligning the cuts with my design were a bit off, but Bambu Lab claims an accuracy of under 0.3mm if you set up everything correctly. You will also be able to use the machine as a pen plotter, and the process is again pretty straightforward, but I haven't done it yet, so I can't provide much information about it. So that was a quick rundown of the non-3D printing features of the H2D. I think the implementation of these features is one of the best I've seen so far, especially with the laser safety precautions, as well as the smart features and an adequate software solution right at the start. Getting started, even if you've never worked with these tools, is easy due to the tutorials, but I believe it will really shine once we can find more and more projects on MakerWorld that users can do themselves and learn from them to realize their own ideas. This could transform such a gadget into a really useful tool, because in many other systems the learning curve was pretty steep, which Bambu Lab will address with their own pre-made projects and the entire ecosystem on MakerWorld. I've met some of the higher ups at Bambu Lab, and many of them are makers at heart who build their own RC projects with a huge passion. So even though I'm still unsure whether it's a good idea to create a machine that tries to do everything or to focus on their core competence in 3D printing, I think they've produced the machine they wanted. It not only 3D prints, but also combines it with sheet fabrication and decorative decals. But what's your opinion on this? I'd appreciate hearing it down in the comments. There will be an upgrade kit in the future to add the laser to a regular H2D, but that will likely cost more than the current markup between the versions. I believe the less expensive upgrade with the drag knife cutter might be even more appealing to some, but we'll see. So there we have it. That's Bambu Labs' new H2D, a powerful maker station with a new generation of 3D printing system and a capable laser cutter and plotter. I didn't get the impression that they compromised on the 3D printing aspect in order to integrate several technologies into one machine, other than sacrificing some visual appeal due to the green plastic doors. I think many people will be very happy with what Bambu Lab is bringing to the market, although the price point might be too high for those who hope for a second generation X or P series machine at a significantly lower price. Yet, if you're paying the price, you'll receive a machine that's exceptionally well built and comes with all the bells and whistles you can imagine. It can work with almost any materials on the market, from regular PLA to high temperature nylons or PPS, thanks to a better hot end and the climate control chamber. It's faster in multicolor printing than its smaller siblings, but if you plan to use more than 2 colors, it doesn't quite match the speeds and the versatility of a tool changer, which may only be important to a small minority. It has other strengths and is obviously smaller, so it definitely doesn't make the Prusa XL obsolete. I rather feel that the better dual nozzle system will be a big challenge for Ultimaker, and the laser and drag knife will convert some from a snap maker to Bambu Labs' new machine. One of my highlights are the new AMS systems with their drying capabilities, and I love that they're fully backward compatible with the older printers once the firmware update arrives, and will even work on the A1. Share your thoughts about this machine in the comments, and if you have interesting questions about the machine, design decisions, or anything else from my talk with Bambu Lab and Dr. Tao, feel free to comment. That's it, I'm definitely putting the H2D through its paces, and I'm really looking forward to seeing what more talented people than I will do with its unique capabilities. Thanks for watching, everyone. I hope you found this video interesting. If you want to support my work, head over to Patreon or become a YouTube member. Also, check out the other videos in my library. I hope to see you in the next one. Auf Wiedersehen and goodbye.